In this video, we want to learn about remainder theorem. Remainder of dividing polynomial px by x minus a is p of a. So we can find remainder of a division without actually dividing the polynomial by x minus a. Simply, to find the remainder of dividing polynomial px, any polynomial, by x minus a, let's say x minus 2 or x minus 3 or x minus 4, simply we have to plug in the number a in the polynomial and we calculate the p of a and we can find the remainder. To understand this better, let me show you an example. Consider this polynomial x to the 3 plus 2x to the 2 minus 5x minus 1. And let's say we want to divide this polynomial by x minus 2. And we are looking to know what is the remainder of this division. So attention, we are not looking for the whole division. We are not looking for quotient. Just we want to know what is the remainder of dividing this polynomial by x minus 2. Based on the remainder theorem, we have to plug in 2 in this expression, calculate the value of this expression at 2, and it gives you the remainder. So for this, I am naming this expression here p of x. And to find the remainder, simply plug in 2 in that expression. It would be 2 to the 3 plus 2 times 2 to the 2 minus 5 times 2 minus 1. If we calculate this, equals to 8 plus 8 minus 10 minus 1. 16 minus 10 is 6, 6 minus 1 is 5. So remainder is 5. If you want to check this is remainder, you can do synthetic division or long division. But based on remainder theorem, we know that definitely this answer is right. So we can find remainder of division without any division. Let me show you another example. Suppose we have this polynomial x to the 4 minus x to the 3 plus 2x minus 1. And we want to divide this polynomial by x plus, for example, 3. What is the remainder? So we want to find the remainder. So we are asked to find the remainder of this division. Based on the remainder theorem, we are not going to divide these two polynomials by each other. Simply, we plug in negative 3 in this expression. If we name this expression p, we plug in expression p negative 3. Maybe you wonder why I plug in negative 3. Attention, based on the remainder theorem, if you want to know what is the remainder, if you divide by x minus a, you plug in a here. Here is negative a, but you plug in a, opposite sign. So if you want to divide the polynomial by x plus 3, you have to plug in negative 3, the opposite sign. This is very important. Not same number that appeared here. Opposite sign of this number, you plug in the expression, and then you can find the remainder. So here, remainder would be negative 3 to the power of 4 minus negative 3 to the power of 3 plus 2 times negative 3 minus 1. Negative 3 to the 4 is 81. Negative 3 to the 3 is 27, negative 27. By a negative outside, it would be plus 27. Minus 6 minus 1. 81 plus 27 is 108. 108 minus 6 minus 1 would be 101. So remainder is 101. Now look at this example here. Use remainder theorem to find remainder of dividing this polynomial by x minus 2. We know that for finding the remainder, what we have to do? We look at this number. The opposite sign of that number is x minus 2, so we have to plug in 2 in the polynomial for finding the remainder. P of 2 would be 2 to the 3 plus 2 times 2 to the 2 minus 5 times 2 minus 1. It equals to 8 plus 8 minus 10 minus 1. 8 plus 8 is 16, 16 minus 10 is 6, 6 minus 1 is 5. So remainder is 5. In the second part of the question, we are asked to verify this answer using synthetic division. We know that the remainder is 5, but we want to verify. We are asked to do this. So we are going to do synthetic division to verify that remainder is 5. If you remember synthetic division, for doing synthetic division, we draw something like this always. We put the coefficients of the polynomial in order from the highest order to the lowest degree from the highest degree to the lowest degree in order in here. This is the way we do synthetic division. The first coefficient, the coefficient of x to the 3 is 1. So we start with 1. Then we have 2, then negative 5, and at the end negative 1. And similar to the remainder theorem, we change the sign of this number, opposite sign of this number, we have to put it here. So we look at this number, it's x, the number is negative 2, so what number we have to put here? Positive 2 or 2. Based on the synthetic division, we bring this number down, 1. We multiply this number by this, so 1 times 2 is 2. We put it here. This is the way that we do synthetic division. If you don't remember synthetic division, please watch my video about synthetic division. 2 plus 2, we add the two numbers that are below each other. 2 plus 2 is 4. Then again, we multiply 4 by 2. 4 times 2 is 8. So we have to put 8 here. Negative 5 plus 8 is 3. 3 times 2 is 6. Negative 1 plus 6 is 5. This part of the synthetic division always shows the quotient. The last number that appears in the synthetic division is the remainder. Here we are not interested in these numbers. These are about the quotient, but we are not asked about quotient. We are asked to verify your answer using synthetic division. Based on synthetic division, we know that the last number that appears in the synthetic division is remainder. And as you can see, this number is the same as this number that we got from remainder theorem. Now, look at this question. Determine the remainder resulting from division of x to the 4 plus x to the 3 minus 2x to the 2 plus 3x minus 7 by x plus 2. For finding the remainder, we use remainder theorem. It's the easiest way. We name this expression p of x or f of x, whatever you want to name it, and we plug in negative 2. Remember, opposite sign. If we plug in negative 2, it would be negative 2 to the 4 plus negative 2 to the 3 minus 2 times negative 2 to the 2 plus 3 times negative 2 minus 7. Always be careful with negative numbers. Negative 2 to the 4 is 16, negative 2 to the 3 is negative 8, negative 2 to the 2 is 4, but times the negative 2 that is outside is negative 8. Then we have negative 6 minus 7. 16 minus 8 is 0. 0 minus 6 is negative 6. Negative 6 minus 7 is negative 13. So remainder is negative 13. As you can see, with the aim of remainder theorem, we can answer questions easily. Now look at this question. Find value of m if remainder is 7. This is a little different question. We are given a polynomial. We want to figure out the value of m. M is unknown, such that when we divide this polynomial by x minus 3, remainder be equal to 7. Based on remainder theorem, we know that remainder of this division can be calculated simply by substituting 3 in this polynomial. Let me suppose this as p. So for finding remainder, for a moment forget this. Focus on the division. We know that based on remainder theorem, if we divide this polynomial by x minus 3, the remainder would be, plug in this 3 in this expression, the result would give you the value of the remainder. This is based on remainder theorem. If we plug in 3, we have 3 to the 3 minus 2 times 3 to the 2 plus m times 3 minus 6. This equals to 27 minus 18 plus 3m minus 6. 27 minus 18 is 9. 9 minus 6 is 3. So remainder is 3 plus 3m. Now please pay attention. We want to figure out the value of m such that the remainder is 7. So we want this remainder that we got from remainder theorem be equal to 7. So 3 plus 3m should be equal to 7. And from this, 3m is 4. Subtract 3 from both sides. Then 3m is 4. And from this, m equals 4 over 3. This is the value of m. For what value of a will the polynomial px is 2x to the 3 minus 3x to the 2 plus ax plus 1 have the same remainder when it is divided by x minus 2 and by x plus 1. So we want to find the value of the unknown a. The a is the unknown. If we look at the equation given for the polynomial, we have ax, so a is the unknown. We want to find the value of a's such that when we divide this polynomial by x minus 2, the remainder is the same as the remainder that when we divide it by x plus 1 is. Based on remainder theorem, we know that the value of the remainders is p of 2 and p of negative 1. If we divide this polynomial by x minus 2, the remainder based on remainder theorem is equal to p of 2. And if we divide this polynomial by x plus 1, the remainder is p of negative 1. So these two remainder should be equal. And then by setting them equal to each other, we can find the value of a. So let's see what is the value of p of 2. We plug in 2 in the given equation for the polynomial, and then we have the value of the p of 2 is 2 times 2 to the 3 minus 3 times 2 to the 2 plus a times 2 or 2a plus 1. 2 to the 3 is 8 times 2 is 16. 2 to the 2 is 4 times 3 is 12. So 16 minus 12 is 4. 4 plus 1 is 5. So the remainder is 2a plus 5. For p of negative 1, we plug in negative 1. Then we have 2 times negative 1 to the 3 minus 3 times negative 1 to the 2 plus a times negative 1, or basically negative a plus 1. Negative 1 to the 3 is negative 1 times 2 is negative 2. So this equals to negative 2. Negative 1 to the 2 is 1 times negative 3 is negative 3. Negative 1 times a is negative a plus 1. Minus 2 minus 3 minus 5 plus 1 is minus 4. So it equals to minus a minus 4. Now these two remainder should be equal to each other. And then we can find the value of a. Two a plus 5 is equal to negative a minus 4. If we move a to the left, then we have 3a. And if we move 5 to the right, we have minus 4 minus 5 is minus 9. And from here, by dividing both sides by 3, a is negative 3. Let's look at the next question. When the polynomial px given by this equation 3x to the 2 plus 6x minus 10 is divided by x plus m, the remainder is 14. Find the value or values of m. Based on remainder theorem again, we know that when we divide a polynomial by x minus a, the value of remainder is p of a. So if we divide this polynomial by x plus m, what would be the value of the remainder? The value of remainder is p of m or p of negative m. Look at here. When we have x minus a, the value of the remainder is p of a. So we switch the sign of this number. So if it is x plus m, the value of the remainder is p of negative m. So we can simply find the value of the remainder by substituting negative m in the given equation for the polynomial. P of negative m equals 3 times negative m to the 2 plus 6 times negative m minus 10. If we simplify, this equals to 3m to the 2 minus 6m minus 10. But based on the information given in the question, we know that the remainder should be equal to 14. So this answer that we got from remainder theorem is 14. So we have to set this remainder equal to 14. Now we solve this for m and we can find the value of m. We move everything to the left, then we have 3m to the 2 minus 6m minus 24 equals 0. To solve this quadratic equation, we factor 3 because 3 is common between these three terms. So we factor 3. Then we have m to the 2 minus 2m minus 6 equal to 0. Not minus 6 minus, of course, 8 because we factor 3. Now look at the bracket m to the 2 minus 2m minus 8. We are looking for two numbers that their product is negative 8. Their sum is negative 2. What are those numbers? Those numbers are negative 4 and plus 2. If we set this equal to 0, from solving this equation we can find m. If we set this bracket equal to 0, m is 4. And if we set the other bracket equal to 0, m is negative 2. So these are the two values for m that makes the remainder of dividing the given polynomial by x plus m equal to 14. Now let's see the next question. When the polynomial 3x to the 2, 3x to the 3 plus x to the 2, ax to the 2 plus bx minus 8 is divided by x minus 2, remainder is negative 6. And when it is divided by x plus 1, remainder is negative 17. Find the values of a and b. So this question is a little harder because basically we have two unknowns. But attention, we have also two information. When it is divided by x minus 2, remainder is negative 6. And when it is divided by x plus 1, remainder is negative 17. Let us start solving the question. Again, based on remainder theorem, we know that when it is divided by x minus 2, remainder is basically p of 2 based on remainder theorem. We substitute 2 in the given equation, then we have 3 times 2 to the 3 plus a times 2 to the 2. 2 to the 2 is 4 times a is 4a. b times 2 is 2b minus 8. 2 to the 3 is 8 times 3, 24, minus 8 at the end. 24 minus 8 is 16. So we can rewrite this as 4a plus 2b plus 16. But we know that this remainder is negative 6. So this expression should be equal to negative 6. Let me write down that here. So 4a plus 2b minus 16 is negative 6. Now let's see what is remainder when we divide it by x plus 1. For finding remainder when we divide the given polynomial by x plus 1, based on remainder theorem, we have to find the value of p of negative 1. And if we plug in negative 1, then we have 3 times negative 1 to the 3. Plus a times negative 1 to the 2 plus b times negative 1 minus 8. Negative 1 to the 8 is negative 1. Times 3 is negative 3. We have a negative 8 at the end, so this is in total negative 11. Negative 1 to the 2 is 1, times a is a, so this equals to a minus b minus 11. And based on information given in the question, we know that this should equal to negative 17. Now we have a system of equation involving two variables, two unknowns, a and b, but we have two equations, so we can solve it. For solving this system of equation, let me rewrite the equations again in the proper form. From the first equation, I move negative 16 to the right side and it becomes positive 16. Minus 6 is 10. Or in another word, we add 16 to the both sides. Then we have 4a plus 2b equals 10. From the second equation, we have a minus b equals to 11 minus 17 equals negative 6. For solving this system of equation, first we notice that the first equation, the both sides, we have a multiple of 2. So we can factor a 2 from the left and cancel from the right. So if we divide all the terms in the left and the right by 2, then we have this simpler equation, 2a plus b equals 5. The second equation is a minus b equals negative 6. For solving this system of equation, either you can use elimination method or substitution method, which in this case, elimination method is easier. If you pay attention, in the first equation we have b, in the second equation we have negative b. So if we add these two equations, left side to the left side and right side to the right side, b cancels from the two equations. And then simply we can find the value of a. 2a plus a is 3a. b minus b cancels. 5 minus 6 is negative 1. So a from here is negative 1 over 3. Now that we have the value of a, we can find the value of b by substituting this value in one of these equations that we have here. For example, if we substitute negative 1/3 in the second equation, then we have negative 1 over 3 minus b equals negative 6. If we multiply left side and the right side of this equation by a negative to get rid of all of these negatives that we have, then we have 1/3 plus b equals 6. And from this, b equals 6 minus 1 over 3. By a simple common denominator, this is 18 over 3 minus 1 over 3. This equals to 17 over 3. I hope by watching this video, you have learned what is remainder theorem and how to use it to answer questions about polynomials related to remainder of a division. If you like this video, please subscribe in my channel and see you in the next videos.